Hey all, we're going to do a sig test number 3 here, other derivative stuff such as implicit differentiation and chain rule and some stuff like that. All right, so on number 1 here, you're being asked to find dy dx, so the derivative of y with respect to x in terms of x and y, which basically means we're going to take the derivative with respect to x of this whole thing. The derivative with respect to x of 3x is 3. And then the derivative on the right-hand side, we're going to need to use a little bit of chain rule. So it's 2 times the inside times the derivative of the inside. So to take the derivative of this, we're going to need to use product rule. So u prime v, v prime u. So u prime v, right? So u prime is 4x times v, which is y, plus v prime is y prime times 2x squared. And when you take the derivative of this, it's just nothing, right? So you don't have to worry about that. And this guy right here is a 1, right? Because we subtracted from 2 and we got 1. So here we are on this. Our goal is to get the y prime by itself. The y prime is right here. So we need to figure out how to do that. First suggestion is, let's go ahead and just clean this up. Let's distribute this 2 in here. Right, it's this guy times, and again, we're trying to get this by itself. What I want to do is I want to just take this whole blob right here and distribute it in. And so what we get is so you can see it's just this guy times this, and then the same guy times that second term. And still our goal is to get this piece by itself. So we can subtract this one and then divide by whatever else is in there. So what we're going to get is 3 minus, and let's go and clean this up too. 4 times 4 is 16. X times x squared is x cubed. Y times y is y squared. Plus, this piece is always also going to be negative because we're distributing that negative in there. Minus 16xy, and this is going to equal 4xy plus 4 times y prime times 2x squared. So again, we're trying to get this by itself, so we're going to divide by everything that's not that. So I'm going to divide by that. And what this is going to give us is 3 minus 16x cubed y squared minus 16xy. On the bottom, let's go and just clean this up, right? Distribute that in there. We're going to get 8x to the 4th plus 8x squared. And this is equal to y prime, which we're done. All right. The difference in the second problem is that it wants at a given point, right? We have to find the derivative at this point, but it is starts out the same, right? We're going to take the derivative with respect to x of this whole thing. Notice a little product going on here. We're going to have to use product rule, right? U prime v plus v prime u. We're going to get 3x squared times y squared plus 2y y prime times x cubed equals, we're on the right hand side, derivative of 2x is that, plus 8y y prime. The nice thing about this one is we don't actually have to go all the way and solve for y prime, right? We can actually just plug in these numbers for x and y, and then it'll become a little bit easier to simplify. So I'm just going to write these out. Right, put parentheses everywhere there's a variable. We don't know y prime, so it has to stay as it is. right? That's what we're going to end up trying to get by itself. And we're just going to plug in everywhere there was an x, we're going to plug in x. And everywhere there was a y, we're going to plug in the y coordinate. All right, so here goes. X is 2. So 2 goes there, 2 goes there, 2 goes there. And y was 1, so 1 goes there, 1 goes there, 1 goes there. And we do this. This piece becomes 4 times 3, 12, plus this piece becomes 16y prime, 4, 8y prime. So just solving this equation now. Let's move the 4 over. We're going to get, I'll just write it up here so we don't confuse anybody. So we're going to go ahead and subtract, it doesn't matter what we do this, subtract 4 on both sides, and let's go ahead and subtract 16y prime on both sides. So we're going to get 8 equals negative 8y prime, therefore y prime is, divide both sides by negative 8, y prime is negative 1. All right, so that's what we should get on that one. All right, next piece is differentiate function with respect to given variable. We're given h of s and we're given this, so basically we're just trying to take the derivative of that. This is like a big chain rule problem. So we're going to do h prime. Oh no, what's going on? Okay, here we are. H prime of what? Stop it. Hold on a second. Okay, good. It's working again. So we're just trying to take the derivative. So it's going to become h prime of s equals, first you got to take the derivative of the outside, which is this whole thing. So it's going to be 5, this whole thing to the 4th. And then you have to multiply by the derivative of the inside. Right? This is the derivative of inside, which is the derivative of this piece. So that's 2. And you have another inside. That constant goes away. So I don't need this giant parenthesis. We can stop it right there. And then we have to multiply by the derivative of this inside piece, which is 6s squared. And, you know, that's just what that one is. Let's leave it like that. Okay, next one is going to either be a quotient rule or a product rule. We're trying to take the derivative of this. In this case, it's product rule. There's a u and the v, so the y prime is going to be u prime v plus v prime u. In this case, u prime is 10x to the 4th times v, which is cosine 4x to the 4th. We're going to add that to v prime, which is negative sine 4x to the 4th times the derivative of the inside is 16x to the 3rd times u, which is 2x to the 5th plus 3. Right? What is this? This is u prime. This is v. This is v prime. And that's u. And to clean it up, you could change this symbol just to a big minus sign, right? Just change it to a big minus. And we could multiply these two together. So let's go ahead and do that just to practice, because multiple choice tests not going to ever just leave it like that. So it's going to be minus 32x to the 8th plus 48x to the 3rd times sine 4x to the 4th. Right, we just multiplied that times that and got this thing. And we'll just leave it like that. That's plenty good. All right, and be aware that it might be a quotient rule problem, right? Or something like that. So there you go. That's it.